Super, thanks a lot. I'm super glad to be here on stage. My first time on the conference, and I was really, I really already liked the discussion that we had before here on stage, because it also talked about whether you prefer stories or whether you really prefer to have deep tech talks. So this talk will probably be a little bit different than the other ones, because there will be quite some energy market in there. So feel free to ask questions afterwards. We will also have Q&A time. But let's talk a little bit about how we really unleash renewables. And why do we talk about that topic? Not working? No. We talk about that topic because time is ticking. The global CO2 budget will be used up in less than 7 years. And then the Earth will become 1.5 degrees, what a coincidence, warmer. That does have a lot of effects. I think everybody by now is aware of that. And this is why there needs to be, something needs to be done, right? And what can be done to fight against that, when you look at how CO2 emissions, and this is a statistic for Germany, are really, or what makes most of the CO2 emissions. The founders of 1.5 degree, actually 2 years ago, thought about what the best impact that we can have on that. And if you look at that chart, it's quite obvious. It's through housing and through the energy sector, how you can have most impact on the CO2 footprint in Germany. And this also works for other countries. If you then look into housing and the energy market, the one thing how it all comes together is really electricity. Heating needs to be electrified, mobility needs to be electrified, and yes, you are receiving or you are consuming your electricity from the grid, and this also needs to be renewable. So 1.5 really is at the center of that, and wants to, I will just click here probably, and wants to have that, wants to solve that problem and bring those different sectors together. So what do we need to do? So in the end, how that problem gets really solved in the fastest way, and this is then how our mission already also came up, is if you change how people consume electricity house by house, street by street, and really device by device. So the first step that needs to be done to really reduce the CO2 footprint and make us more carbon neutral is the technologies that are more carbon neutral, for example, PV, need to be available. And it needs to be easy for consumers. So the first thing on the agenda of 1.5 was to create the one-stop shop for solar, charging, and heat pump. So private house owners can just come to a shop, buy those things, have them easily installed. No struggle to find the right components, no struggle to find someone to get it installed. This actually, especially during COVID, with supply and demand being imbalanced, so many people wanting PV panels to secure their prices, but components being quite scarce, was quite a challenge we put ourselves up to at 1.5. But okay, this can be done, right? And I will talk a little bit about where we stand with that in a minute. Then the second part is to optimize and digitize the process, how things get to the households or to the consumers. Because usually, I mean, Germany has quite a traditional installation scheme, let's say it like that, or installation companies. They are not very digital, and the processes have evolved over time. So what we did there is we developed a operating system for those companies that really helps them from the moment they have the first lead in their CRM system to the moment where a full installation is delivered, to have that all planned digital and to have that all executed and documented in a digital way. So once that is done, most of the companies in the renewable sector actually stop because the hardware is installed, right? But for 1,5, really the third step is to stay with the customers or the owners of the assets over the lifetime of the assets and make most of them. And this is where the unleashing renewables really comes into place. For a moment, let's talk about step 1 and 2, because this is where we, in 2 years' time, already have made a lot of progress. So after 2 years existing, we are now active in 7 markets. We have more than 1,500 employees at 1,5. And for me, always the most important thing on that chart, besides the CO2 impact, which obviously is accumulated across all our customers, is the number of connected systems. Because with every system that gets connected to our world, the CO2 footprint gets reduced. And then, once that is really done, we come to what I mentioned beforehand. We need still to get the third step done. So systems are connected, but why do we need to steer them more intelligent or more in a more intelligent way? I mentioned earlier, technology is there, so everybody can go somewhere and buy a PV panel or a heat pump or a storage system. But once they are installed, they act kind of however they want to, right? So anybody who has ever seen a heat pump or who has a heat pump in their homes knows whenever the buffer charger has a temperature that is too low, it will consume electricity to heat up. Or anyone who ever tried to charge an EV, probably not somewhere where you wanted to leave again, but at home knows you just plug in the EV, then it will start charging. This is fine if you don't really mind where the electricity comes from, but this becomes a challenge once you really, and we will talk about the energy market in a minute, once you want to minimize the impact that you have with that action, and once you want to, for example, want to make most use of what your PV panel is producing. Because if you really have the PV panel on your roof, probably you want the heat pump to use electricity when there is PV produced. Or you want the heat pump to use electricity when there's a lot of wind electricity in the grid. And many people probably have read the headlines when electricity has a negative price, wind power needs to be curtailed because there's too much in the grid. So why wouldn't you want your asset or your heat pump or your EV to use that electricity when it's really there and generated by renewables? So the mission of 1,5 is to connect all those different components into one system. And the magic behind that is a little bit to know what will happen. And this is where then software comes into part, because obviously those assets need to be connected. You need to collect all the different data points that you get from those assets. You need to make sense of those. You need to make predictions. And then you need to steer them according to what's happening. And then the step 1 that we did was to do that in home. So first you only look into, okay, how does the PV forecast look like? When will there be PV production again? When do I supercharge when do I charge my battery with that PV? And when do I use the power from the battery again? So step 1, you optimize everything that is in a home so your assets don't do stupid things anymore. So your assets really talk to each other via, you see the small house in the middle, that's our heartbeat, that's how the product is called, that does the IoT connection in home and then kind of acts as the device to collect the data. This device does in the end steer already for the customers in home, so they make most use of the PV that is produced on their roof. But, and I mentioned the virtual power plant before, this is not where it stops, because this only works two way of what happens inside the home, but in the energy world, there is a lot more happening outside the home. So there are electricity markets at which you can buy electricity or sell electricity, right? And in those markets, the price is then set depending on how much supply and demand at a certain point in time there is. And historically, this has been relatively easy as a market, because historically, you would assume overall what the demand of electricity will be based on how we all would consume. So based on an assumption when we will watch TV, when somebody will cook, or what will happen. And this was the only thing that needed to be forecasted, because the supply was constant or could just be set up to a certain limit, because we had coal power plants, we had nuclear power plants, we had all those power plants in the system, which we basically just asked at any given point in time to produce whatever electricity we needed. But with the renewables coming in, this game has changed. Because with the renewables coming in, the supply of electricity also became fluctuant, because you just can't ask the wind to produce whatever you need, or you can't ask the sun to shine whenever you want to have electricity. So both of the curves, the demand and the supply, they started to vary a lot more, and it was a lot more difficult to bring them together. However, there is a nice effect of that, which is that on this electricity market, in general, the price is low when there's a lot of wind or sun, which obviously makes sense, because then you have oversupply on the markets. Wind is just pushing into the system, and we don't really know even what to do with it. So price is super low when there are renewables, which is a nice coincidence, which obviously you can make use of to reduce the CO2 footprint of consumers, and at the same time also to reduce the price that consumers pay. So in the electricity market, life is not as easy as it sounds. So there are a couple of markets actually. There is one where you would buy electricity a long time ahead. So typically large utilities go there and buy electricity a year, a month ahead, and would assume what the overall demand is. Then you would go a day before and say, okay, now I know a little better what will happen tomorrow. So I adapt my forecast at least on an hourly basis, and I adapt what I buy or what I sell in this market on an hourly basis. And here's an example of spikes that you can get. So just for everyone to compare a little bit, probably you're paying something between 30 cents and 40 cents for your electricity per kilowatt hour in your home. But if you look at that market now, it can go up and down a little. There are even times where you wouldn't pay anything, or there are times when there would be negative prices. And this, the closer we get to real time, the more extreme it gets in the markets. So if you come to the intraday market, then it's kind of 10x from what we've seen before. You can have minus 100 cents per kilowatt hour or plus 700 cents per kilowatt hour, and could really first make money off that, but second also help the system to deal with the huge amount of renewables we have. Because every time a consumer is consuming when there is a negative price, that also helps to integrate more renewables into the system. And then in the end, in real time, it really becomes a super tricky game, because in real time in the electricity system, it's about stabilizing the frequency in the grid. And this also in the past has mainly been done by large power plants and their generators. So they just stabilize the frequency. With more and more renewables coming, it's actually batteries that do those things. So batteries in people's homes starts to do, it's called frequency containment reserve, really start to stabilize the grid. And there, the 510 euros per month is just an example from Sweden, where if you would have a 10 kilowatt peak battery in your home, and you would just participate with that battery in the market, you would have been paid out 510 euros in August this year just for participating. So in the end, what that means is that when you're in the electricity market, you come to the real-time point and you are able to participate with the assets that you have in those markets. They will pay themselves off just like that. So people in Sweden now really started buying batteries and just put them in their cellars to participate in the market. And after a couple of months, a year's time, a year and a half time, these batteries are actually paid off. And afterwards, that batteries can store electricity for those consumers for free, because there is no asset cost anymore involved in that. So participating in those markets for customers and making it accessible for customers really changes the game also with costs when it comes to renewables. So basically, and this leads a little bit to the mission that we have as 1,5, Heartbeat, so the IoT box that we connect in the customer homes, is the system that enables our customers or allows them to live on wind and sunlight. Because it takes all the assets, it kind of steers them, aggregates them, assumes what they need to do so that customers can make most of it and can make use of wind and sunlight. Then once that is done, the question that I get asked a lot is really, what is needed to have an impact in that game? Because probably I can't buy a PV because I don't have a house. Or probably I do already have the systems, but I don't know how to work and connect those. So what is really needed is, from my point of view, use our times in the most efficient way, right? And for me, this is part of the story of why I switched from Google to 1,5, because I really wanted to use my time in a way that it helps us, everyone, to move forward and achieve the 1,5 climate goal or work towards it as hard as possible. And this is a little bit what we do on the right-hand side. This is an example from our customer application, is really to try to make this accessible to everyone. And it's kind of the chance also for me to be on that stage when I talked to Doreen from my team before, is to ask everyone, if you are interested in that mission and if you want to move something, use your knowledge on technology and software in that field. Because there is many things to be done to get it working, right? Yes, there needs to be apps developed. Yes, there needs to be a lot of data handled to get that done. Yes, we as 1,5 build those things. So if you want to be part of it, it is this is also a way to do an impact for that. So not only installing it at your own home, but also working on delivering those solutions to people is a way to have an impact with that. So this is already my last slide, so I think we're fine on time. Our mission really is to make living on wind and sunlight forever for free possible for anyone. And once 1,5 started 2 years ago, in the end it sounded like we were a little bit crazy. Because how can you live on wind and sunlight forever for free? And our founder always says, in the beginning I thought like, I'm not sure whether I can put it out there. But when you start then on that mission of first building that one-stop shop so that people can buy the assets, then second, digitizing the process and the companies that deliver those assets to make it most efficient, you're already 2 steps into the game. So then what needs to be done, the third step, connecting all that assets, making them intelligent, and making the flexibility of those assets available to not only optimize in-home, but also optimize towards the energy market, is the last step that's missing to achieve that. And then the for free is a bonus on top. Because when there is renewables in the grid, this is when electricity is at the cheapest price or even at a negative price. So nowadays, we really believe this mission is not even far away because it's a couple of software updates away from where we are currently with Heartbeat. So with the code, just feel free to scan it because you will end up on my team's jobs page. And then you can start working with us on that mission and helping to make that accessible for everyone.